Heading on this is story problems. And the little subheading of the story problems is using or finding unstated info. Which simply means like this, and first of all, let's just do this, God bless you, God bless you. It goes without being said that you will sketch these out. And that just means you are going to make a rectangle and cut it into pieces and do whatever. Here is an example. Finding unstated information means simply that the problem is not going to tell you some things that you just have to infer. You are smart. You can figure some things out without being told them just because of who you are. For example, 3/4 of the 28 students are boys. 3/4 of the 28 students are boys. Okay. They could ask you a number of questions here. The most logical question they would ask you is, how many students are boys? But the book's not going to ask you. It might ask you, how many students are girls? So you cannot look at that and go, oh, they don't tell me anything about girls. Well, they do, because you being smart 6th graders know that either you're a boy or a girl, despite common worldly views of things. When you draw this rectangle out, what does that big rectangle stand for?
1, 3,
No.
4.
It stands for 28 students. Not 1 or 3/4. The fraction they give you, 3/4, that's how many are boys. So if you cut this into 4 pieces, you know that 3 of the 4 pieces are boys. Here is the part that you have to infer, that they don't tell you, that's unstated, is that if this little part here is boys, then the other 1/4 up here would have to be girls. Just the way it works in our society here, for the most part. And you still do it the same way. You're taking 28 and cutting it into 4 equal pieces, so each piece is 7. You would know that 21 are boys, but it doesn't ask you that. It asks you how many are girls. That's unstated, but you know that there would have to be 7 girls. That should not be terribly difficult for you. Do you kind of get the gist of that?
Yeah.
3-dimensionalized. Let's do one more. Well, maybe, just maybe, you'll get the gist of this. Well, look in your book at page 401. Let's just look at practice. Letter A, B, C, D, E, and F. Are you there with me? You see page 401? It says diagram this statement, which is just what we did right there. Then answer the questions. 3/8 of the 40 little engines could climb the hill. So what would we have there? You draw this. What does the big rectangle stand for? How many engines are there?
40.
40 engines. I know that 3/8 of them could climb the hill. So let's diagram that. I'm cutting this into 8 equal pieces. So I take 40 and cut it into 8 equal pieces. How much is each piece? I know it's hard math. Every one of these pieces is 5. We know that 3/8 of them, 3 of those 8 pieces could climb. And then what do you have to infer from that? If 3 out of 8 could climb the hill, then probably, most likely, and almost positively, Max, Let me rephrase the question. Max, if 3/8 of those little engines could climb the hill, the other part probably are the ones that couldn't climb the hill, which would be 5/8 of them. Could not. Now the question they ask you, letter A, is how many parts was the group divided? Well, what is that? How many parts was it divided? 8 groups, right? I cut my little piece into 8. Yes, Mr. Hahn, we're right there on the same page. Letter B says how many engines were in each part? How many engines are in each part? 5. Letter C asks for how many parts could climb the hill? 3. How many total? How many parts?
15.
No, didn't say how many engines. It said how many parts did I cut? How many parts of my 8 could climb the hill? Letter D says how many engines could climb the hill. There's your question. 15 engines. Letter E asks for how many parts could not climb the hill? 5. And then letter F, how many engines is 5 parts? 25. 5, 10, 15, 20, 25. So all of those questions you can answer based on that one little statement. Again, I need to see the little diagram that they show there. Maybe you've read the book about the poor little train that could climb the hill.